All right, guys, we are in study mode, getting ready for this test, all right? Okay, so this whole distance learning thing is brand new to all of us teachers, and I don't know if this is the right way to help you guys study for this, but this is how I'm going to do it. And yeah, so this is going to be an Edpuzzle, and you're going to be answering questions, and just so that for my peace of mind, you are watching the video, and this is how you're preparing for this test, and I'm making sure that you're doing it. So yeah, I wouldn't do this normally. Just, I guess, consider me your big sister, and I'm making sure that you're doing your work. All right, so an arithmetic sequence is given recursively by A1 equals 6. So the first term is 6, and A sub n plus 1, so the next term equals A sub n, which would be the previous term to A sub n plus 1, minus 2. So basically, it's the term minus 2 equals the next term. So since we're subtracting 2 each time, that means this must be our common difference, D. And they want to know, what is an explicit formula for A sub n? Okay, well, to write an explicit formula, that would be A sub n equals A1 plus D times n minus 1. This is the formula. So let's actually use that formula and write one for this particular situation. So A sub n equals, the first term is 6 plus D, but D is negative, so I'm going to put negative 2 times n minus 1. And then simplify it. So distribute the negative 2. So we'll get 6 minus the 2n, negative 2 times negative 1 is a positive 2. And we'll get, let's see, I like to put it in mx plus b form. So I like to put the variable term first, negative 2n, and then 6 plus 2, these are my like terms. 6 plus 2 is 8. So negative 2n plus 8. So A sub n equals negative 2n plus 8 is the answer. All right, skipping number 2, skipping number 3, on to number 4. Number 4 is, what is the nth term of the geometric sequence with the second term equals A2 equals 36, and the third term, A3 equals 24. So we have the second term and the third term. So it's like we have a sequence like this. This is the first term, blank, I don't know what it is. The second term is 36. The third term is 24, ... Okay. Well, to write an equation to find the nth term, sorry, I forgot where I was going with this. To write an equation to figure out what the nth term is, that means they want A sub n equals. They want the explicit formula. Okay. Well, I need to figure out what the first term is, and I need to figure out what the common ratio is, because this is a geometric sequence, so that means we're multiplying by a number each time. And, excuse me, since these numbers appear to be getting smaller, because we go from a 36 to a 24, I need to figure out, well, what fraction is being multiplied by then, okay? All right, so to figure that out, what you can do, the common ratio are, we can take the term 24. And since something was multiplied by 36 to equal 24, we could take 24 and divide by 36. Go in the reverse. The opposite of multiplication is division. And then when we reduce this, let's see, 12 can go into 24 and to 36, right? So 12 can go into 24 2 times, and 12 can go into 36 3 times. So the common ratio must be a 2/3. Well, let's check it. Let's verify that this is going to work. So let's see, 36 over 1 times 2 over 3. Is that going to equal 24? Well, when we're multiplying fractions, we can reduce. 3 goes into 36 12 times, and 12 times 2 is 24. It works. Check. Okay, so R is the common ratio, and we need to go backwards and find what this first term is. So remember, something times 2/3 equals 36. Well, let's write a little equation. So 2/3 times x, that's our something, is going to equal 36. We just figure out what the something is. Okay. Well, I need to solve for x, and anytime you need to get rid of a fraction in front of a variable, you just multiply by its reciprocal. Okay, so those will cross cancel, and you get x equals 2 goes into 36 12 times? No. 18 times? 18 times 3, what's that? Where's my calculator? I can't math in my head tonight. 18 times 3 is 54. So that means that the first term is 54. So let's check this out. Let's see if it works. 54 times, now I need to multiply by 2/3. So I'm going to multiply by parentheses 2 divided by 3 because that will represent 2/3. And I get 36. And 36 times 2/3 equals 24. So it's working. All right, so we have our first term. We have the common ratio. These are the things that we need to write the explicit formula for this particular situation. So the explicit formula for a geometric sequence is a sub n equals a1 times r to the n minus 1 power. Okay, so for this particular situation, and I'm going to box that for you so you know that's a formula that you might want to add to an index card or to a little cheat sheet of notes, okay, so that you have everything all together. All right, so for this particular situation, a sub n equals a1, the first term is a 54. The r, the common ratio, was 2/3, and then to the n minus 1 power. So when you're writing a formula for a geometric sequence, all you need to replace is what the first term is and what r is. And then with a arithmetic sequence, all you have to replace is the a1 and the d, but you have to simplify it. So you have to distribute and then combine like terms. For geometric sequences, you just plug it in and then you're done. There's nothing to simplify. So those are actually a little bit easier. And from that quiz that we took with that, remember Sultana versus HHS on that radio station contest? You guys preferred the geometric sequence. You did better with those than the arithmetic ones just because simplifying it was a bit of a pain. All right, number 5. The figure shows the path of a bouncing ball and how far it travels horizontally. Okay, so it looks like it bounces and then it goes 16 inches and then it goes 12 and then it goes 9. So we could figure out the pattern. It's only going 7 bounces, so let's see. It goes 16 and then 12 and then 9 and then that would be the 4th, 5th, 6th, 7th. Okay, and so let's figure out the rest of these. So how are these decreasing? So we need to figure that out. So let's see, are we adding or subtracting the same number each time? Well, I know that 12 minus 3 is 9, but 16 minus 3 would be 13, not 12. So it's not arithmetic, it's got to be geometric. So 16 times something is going to equal 12. So let's divide both sides by 16. And x is going to equal, let's see, 4 goes into 12 3 times, 4 goes into 16 4 times. So it looks like we're multiplying by 3/4. Let's check this out. 16 times parentheses 3/4 is 12. Yep. And then times parentheses 3/4 should be 9. It's 9. And then times parentheses 3/4, we get 6.75. And then times parentheses 3/4, 5.0625. So I'm going to put 5.06. Instead of multiplying by 3 divided by 4, what decimal could I be multiplying by instead? 3/4 is the same as 0.75. So the next one would be 3.797. And then multiply that by 0.75. I get 2.85. Okay. So it was asking for how many inches will the ball have traveled after 7 bounces. So that means we've got to add them all up. So we'll have 16 plus 12 plus 9 plus 6.75 plus 5.06 plus 3.797 plus 2.85 equals, I'm just going to type this all into my calculator, 16 plus 12 plus 9 plus 6.75 plus 5.06, making sure I'm typing it in correctly, plus 3.797 plus 2.85. And I'm getting 55.457. So the closest answer to that is the 55.5. And that's the correct answer. Turn the page. We get to skip number 6, number 7, and number 8. So we're going to be on number 9. So number 9 says the volume of a rectangular box is given by the function v of w equals 36 minus 4w times w squared. What is a reasonable domain for the function in this situation? Okay, well, when we're trying to find a reasonable domain that has to do with the x's, right? Well, in this case, our x is basically the w. Well, we got to break apart these two factors and set them each equal to 0, so that we can find the zeros, because that'll help us figure out when it's going to hit the x-axis. So 36 minus 4w equals 0, and w squared equals 0. Just like that, that quiz that we took with the box and cutting out the corners and all that. All right, so if I subtract 36 from both sides, I'll get negative 4w equals negative 36. Divide both sides by negative 4, and w equals 9. Okay, if I solve for w squared, square root both sides, well, the square root of 0 is still 0, so w equals 0. And it's not plus or minus 0 because 0 is neither positive nor negative. So if w is 0, 0 times anything is 0, but that would mean that the volume is 0. So that means that w can't be 0. Remember, we're finding what w can't be, which means that w can't be 9 either, because 4 times 9 is 36, and 36 minus 36 is 0. So w can't equal 9 either, but that is our reasonable domain. That means that we can go from 0 to 9, so anything in between 0 and 9 will work, but we can't equal 0 and we can't equal 9. So that means we're going to have w in the middle. Your inequality symbols will always be less than symbols when it's a compound statement, and we're going from 0 to 9. It always goes from smallest to biggest. So the only option that has exactly that is letter C. And that was number 9. Number 10, which of the following graphs shows a cubic function with 2 distinct zeros? 2 distinct zeros means that we can see that it's going to cross the x-axis twice. So 2 x-intercepts. Okay, so they're not imaginary. All right, and cubic means that we're going to have an x to the third. Okay, and the x to the third is going to look like that if it's positive, or like this if it's negative. Okay, so A is not it. This has the upside down funky w, so it's basically a negative x to the fourth. It's an even degree. That's not what we want. This one is a cubic. It's a negative cubic. Okay. But it's only crossing through the x-axis once. So this only has one distinct 0. So this one's not it because we want a cubic that has 2 distinct zeros. Okay, well, letter C, this one's also a cubic, and it is crossing through twice. So this one is the cubic. It's a negative cubic, just like that one is, but it has 2 zeros, 2 distinct ones, so C is it. But because we're good math students, we're going to check letter D because you never know, just in case. This one is also a cubic. This one's a positive cubic. Now, it didn't say if it could be positive or negative, so that doesn't matter. But this one has 3 distinct zeros. So this one is not it because we're looking for one that has 2 distinct zeros. Okay. Just wanted to go through and explain why certain options weren't the correct options so that you can understand that clearly. All right, next one. Number 11. Which statement accurately describes the end behavior of the graph of a polynomial of even degree with a negative leading coefficient? So we're looking at which one of these is the correct end behavior for something that has an even degree with a negative leading coefficient. So think of our good old x squared. And if it's like a negative x squared, that means that it's going to be a downward facing parabola. So that means as we are going to negative infinity, it's going down to negative infinity. As we go to positive infinity on the x, it's going down to negative infinity on the right. Okay, so this is what I'm looking for. So the first one says as x goes to negative infinity, y goes to negative infinity. Okay, check. That's working. And as x goes to positive infinity, f of x or y goes to negative infinity. Hey, that's exactly what I have there. I think A is the answer. Letter B, as x goes to negative infinity, y goes to negative infinity. Check, that works. And as x goes to positive infinity, y goes to positive infinity. Nope, we're going to negative infinity. So that's why that's not it, because this is not true. Letter C, as x goes to negative infinity, y goes to positive infinity. Nope, that's not true. We're going to negative infinity. So that's why C wasn't it. And D, as x goes to negative infinity, y goes to positive infinity. Again, that's incorrect. Okay, so A is the correct option. But it's always good to check all 4 because what if you missed something or you read it too quickly? It happens. We're human. We make those mistakes. So we need to take those steps so that we avoid those mistakes. Okay. Number 12, it says classify each polynomial in the table as an even function, an odd function, or neither. Select exactly one choice in each row. So let me zoom in on these. So first one is f of x equals 8x. And that 8x, that variable, is just an x. So that means it's to the first power. They don't put an exponent on something that's to the first power. So we assume it to be. Well, 1 is an odd number and there's no other terms. So this would be considered an odd function. G of x equals 8 or x to the 8th plus 1. Well, a constant means that we have a variable there, we just don't see it because it's to the 0 power and anything to the 0 power is 1. So 0 is an even number and 8 is an even number. So this is an even function. H of x equals 3x plus 5. Well, we know if it's just an x, that means it's to the first power. That's an odd number. But the constant 5 has an x to the 0 power. And 0 is an even number. One's odd and one's even. So this is a neither. It's got to be all or nothing. R of x equals 5x squared minus 3. Well, we know 2 is an even number, and that constant of negative 3 has an x to the 0 power that we don't see written there because we have to assume it. 0 is even, 2 is even, so this is an even degree. V of x equals 8x to the 5th plus 2x cubed. Well, to the 5th power is odd, to the 3rd power is odd. This is an odd function. It's so odd. W of x equals x squared minus 6x plus 9. Well, that's to the second power, and x is to the first power. So I don't even need to look at the 9 because already one's even, one's odd. It's going to be neither. Okay, so it went odd, even, odd, neither. Okay. Number 13. Mark used synthetic division to divide the polynomial x to the fourth plus 2x cubed minus 5x squared plus 9 by x plus 2. His solution, x cubed plus 4x squared plus 3x plus 6 minus 3 over x plus 2, is incorrect. Okay, Mark's work is shown. So we are going to be asked to find where he made his mistake. So let's take a look at his synthetic division. Did he put the correct number in the box? Yes, it should be x equals -2. So -2 should be in the box, and that is. The coefficients are 1, 2, -5, and 9. 1, 2, -5. Oh, I even forgot the 0x because it's missing that first degree term. So yeah, 1, 2, -5, 0, and 9. All those coefficients are there. Okay. Brought down the 1. 1 times -2 is -2. Is 2 minus 2 4? No, that should be a 0. So he messed up in column C. So column C, row 3 should be 0, right? So B is the correct answer there. Okay, skip 14 on to number 15. Which of the following is the complete factorization of 6x cubed minus 9x squared minus 15x? Well, yes, it is a trinomial, but before you try to do product sum, you need to factor out the common factor. And right now, there is a common factor of an x, but there is also a common number, and that is a 3. So divide that out first, and we'll get 2x squared minus 3x minus 5. And now we can do product sum on what's in that trinomial, now that that common factor of 3x has been taken care of. So the product would be 2 times -5, which is -10. It's got to add up to -3. So it's got to be 5 times 2. But which number should get the negative? Probably that 5 if I want -5 plus 2 to add up to -3. These are the droids I'm looking for. Because this is a hard trinomial, we have to do the replacement. Okay, so we'll get 2x squared minus 5x plus 2x minus 5. Break it in half and factor each side. On the left, there is a common factor of just an x, and we'll have 2x minus 5. On the right, 2x minus 5, there's nothing in common, so we have to plot something, so it's a 1. And we need the 2x minus 5 in there anyway, because we need these to be the same. That means we're doing it right, and it's factorable. So the first factor is 2x minus 5. The second is my leftovers. We got to slap them together. X plus 1. Okay. And let's not forget that we have that factor of 3x that's in the front. And so it's 3x times 2x minus 5 times x plus 1. And that is the complete factorization of this polynomial. And that would be letter D. Number 16. What is the factorization of 8 minus x cubed? Now, I know that this is out of order. We normally have the variable term first, but that doesn't mean that we're going to do this any differently. It is a difference of 2 perfect cubes. So we got to figure out, well, what is being cubed? Well, to get an 8, 2 must be cubed because 2 times 2 times 2 is 8. And to get an x cubed, that's easy. It's just an x cubed. So this is my A, this is my B. And we need the formula for a difference of cubes. So I'm going to write that over to the right here. So whenever you have A cubed minus B cubed, and remember it's minus plus plus, you'll have A minus B times A squared plus AB plus B squared. Minus plus plus. So following that pattern but using this A and this B, A is 2, B is X, we'll get 2 minus X times A squared would be 2 squared, which is 4, plus A times B, so 2 times X is 2X, plus B squared, so that would be X squared. So 2 minus X times 4 plus 2X plus X squared. So let's find our options. This one says 2 plus X, so that's not it. That's not it. 2 minus X, 4 plus 2X plus X squared. C is it. D is not it because it has a 4X in the middle, and that's incorrect. So C is the correct answer to number 16. Number 17. All right, it says the polynomial P of X has zeros. X equals -1, X equals 1 minus 2i, and X equals 3. There are no other real zeros. Which of the following is the correct degree for the polynomial? Oh, so we don't even need to multiply this out. We just need to know the correct degree. So how many zeros it has will tell us the degree. But we got to be careful. I see an I in there, and I's always come in pairs. So, since we know that that is true, complex numbers always come in pairs. If I have X equals 1 minus 2i, then I also have its conjugate, complex conjugate, 1 plus 2i. Okay, so I have 1, 2, 3, 4 zeros. So there's 4 zeros total. So that means that this must be to the 4th degree. So that would be B. Number 18, it says write a polynomial function f of x of degree 3 that has zeros -2, 1, and 4, for which f of 0 equals -16. Complete the function by entering the appropriate numbers in the boxes, entering 0 if the term is not present in the function. Okay, so first of all, we have our zeros. At x equals -2, x equals 1, and x equals 4. Okay. F of 0 equals 16 means the point when x is 0, y is -16. So that's basically telling us what the y-intercept is. So that's another clue for this function. Okay, so what we need to do is we need to work backwards and figure out what polynomial it was. Basically, what are the coefficients to our polynomial? So before it was x equals -2, that means it was a factor of x plus 2. Before it was x equals 1, it was a factor of x minus 1. Before it was x equals 4, it was a factor of x minus 4. And we need to multiply that out. So that's exactly what I'm going to do. But when we multiply out factors, you can only do 2 at a time. So I'm just going to pick the first 2 arbitrarily. You could pick the last 2. You could reorder them and be like eeny, meeny, miny, mo, and multiply those 2, whatever they are. But it doesn't matter. When you're multiplying, order doesn't matter. All right, x times x is x squared. X times -1 is a -1x. -2 times x is a that was a positive 2 times x is a positive 2x. And 2 times -1 is -2. We'll bring this over here. When we combine like terms, we'll get x squared, negative x plus 2x is a 1x minus 2. Okay, but before I write it over here, we still have this factor of x minus 4. Since it's smaller, I like the smaller factor in front. And then the other one is x squared plus x minus 2. And now we're going to multiply that out. Okay, so x times x squared is x cubed. X times x is an x squared. X times negative 2 is a negative 2x. And then the inside terms. Negative 4 times x squared is a negative 4x squared. Negative 4 times x is a negative 4x. And negative 4 times negative 2 is a positive 8. And now we can combine like terms. So we have x cubed, x squared. So 1x squared minus 4x squared is a negative 3x squared. Negative 2x minus 4x is negative 6x. And then plus 8. So the coefficients are, well, the coefficient on the x cubed is just a 1. So I put a 1 in that box. The coefficient on the x squared is a negative 3. So I'm going to put a negative 3 in that box. The coefficient on this on the x is a negative 6. So I'll put a negative 6 in that box. And then the constant is an 8. But wait, there's more. Didn't it say that the y-intercept is negative 16? So shouldn't this 8 be a negative 16? So I jumped the gun a little too soon. That's not the answer. I have one more step. What do I need to multiply by 8 to get negative 16? Well, I know 8 times negative 2 is 16, but I can't just multiply the 8 by a negative 2. I have to multiply everything by negative 2. So when I do that, I'm going to get negative 2x cubed. Negative 2 times negative 3x squared is a positive 6x squared. Negative 2 times 8 is a negative 16. Oops, I forgot the x. Negative 2 times negative 6x is a positive 12x. So let me fix that. And then negative 2 times 8 is a minus 16. I'm running out of room there. So the coefficients are what they cared about to fill in those blank boxes there. So you would fill in the first box with a negative 2, a positive 6, a positive 12, and then a negative 16 as the constant. Okay, so that would have been very different from what I had originally written. So it's funny because as I started writing it, I already realized, I was like, oh, I forgot to do that. But we make mistakes, we got to go with it, and you got to catch our mistakes when we do. That's how we learn. Number 19. So it says a polynomial p of x has a degree 4, and its graph has relative minima at negative 1, 3 and positive 1, 3. How many real zeros does p of x have? Okay, well, what will help with this is we need a visual. What's going on with this graph? Seems simple enough. The numbers are small. So let's just draw a quick sketch. Okay, so it says it's a degree 4. So we know that an x to the 4th is the funky w. It's going to look like that. Okay. It doesn't say if it's positive or negative, but let's take a look at all this. So negative 1, 3 is a relative minima. 1, 2, 3. Minima means that's like the bottom of a hump. And there's also a minima at positive 1, 3. So this tells me that the w has got to be facing up if those are minima. Okay, so if those are minima and that's what this graph is doing, how many real zeros does it have? Well, to have real zeros, it's got to be crossing through the x-axis. But this is not going through the x-axis. So that means that there are no real zeros. No real zeros because they are imaginary. So I got distracted. My husband's yelling at my son in the background. He's getting in trouble for whatever reason. I hate when I forget to press play. I keep getting distracted by my son. But anyways, here's number 20. I had talked to myself and I wasn't even recording, so that's just great, Mrs. Garcia. All right, which of the following could be the leading term of a polynomial whose value decreases as x approaches negative infinity and decreases as x approaches positive infinity? So I draw a picture for that. It says as it's approaching negative infinity on the x, it's decreasing. And as it's approaching positive infinity on the right, it's also decreasing. Okay, so that tells me that the end behaviors are the same. So it's got to be an even degree. And because they're both going down, it's got to be negative. So I'm looking for a negative with an even degree. So automatically the positive ones, they're out. So it's got to be one of these. But 7's an odd number, so it can't be A. So it's got to be B. Number 21, which of the following lists the possible rational roots of P of X? So we need to find the PZs, and that's where we take the factors of the constant divided by the factors of the leading coefficient. So factors of 2 are just 1 and 2. Factors of 6 are 1, 2, 3, and 6. And then when we split them up into how many different things we could try, we'll have 1 over 1, 1 over 2, 1 over 3, 1 over 6, and then with the 2 over 1 is 2. And then 2 over 2 is 1. 1's already on my list. 2 over 3. And then 2 over 6, that reduces to 1/3, which is already on my list. So there's 1, 2, 3, 4, 5, 6 times 2 because they're plus or minus. So basically 12 possible zeros that we could try in synthetic division if we were going to do that. If we were going to go a-hunting we will go. Not really. We just need to figure out, well, our list. And this is our list. So which one of these is correct? Well, the first one wasn't it because it's missing the 1/6. And it's also missing the 1/2. And that's it. The 1/6 and the 1/2, it's what it's missing. Part B, it's got the 1/2, but it's missing the 1/3, the 2/3, and it has a 3 in there. There was no 3. Letter C has it all. And letter D has numbers that we didn't even come up with. Okay. All right, next one. Number 23. It's an even degree function because both ends are facing up. And it's crossing through the x-axis in these 3 places. So because it's the funky W, it's got to be an x to the 4th. It's an even degree, and it should have 4 zeros. Which of the following must be a factor, though? So you get the factors from the zeros. We have a 0 at -3, 0, and 2. -3, 0, and 2. So the factor that was before you get x equals -3 is x plus 3. It's on my list. Check. When you get x equals 0, its factor is an x. Check. When you get x equals 2, its factor was an x minus 2. Check. That's it. Number 24, consider the polynomial x to the 4th minus 18x squared minus 81 and g of x shown in the graph below. So what I did by myself, because I was only talking to myself and not recording, is I have f of x versus g of x. And I just started identifying what I know. First off, I tried to factor it. It ends up not being factorable, so I couldn't factor it to find what the zeros actually are. So that got me stuck, but that's okay. It was an even degree because it's to the 4th power, and it's positive because the leading coefficient is just a positive 1. And the y-intercept, the constant there on the end is the y-intercept, so it's at 0, -81. And I know that there's going to be 4 zeros total. So that's what I know about f of x. G of x is easier to know more about because we see it on the graph. I see that it's crossing the y at 60. So that's its y-intercept, and it has 1, 2, 3 x-intercepts there. And it's a cubic, and because it's up on the left, down on the right, it's got to be an odd negative cubic. Okay, well, cubics are odd anyway. I don't know why I said it that way, but it's a negative cubic. Okay, so I got the y-intercept, the zeros, and the fact that it's an odd negative. So which one of these are true? F of x has more x-intercepts than g of x. Well, this may not necessarily be true. We don't know if all those 4 zeros are real numbers. What if they're all imaginary? What if it's floating above the x-axis? I don't know that, so I can't say that that's true because we don't know. Letter B, f of x has fewer x-intercepts than g of x. Well, that might be possible because there's 3 here, and we don't know if this is going to have that many zeros. Okay. Also, the fact that we know that the y-intercept is down at -81, so it's down here, it is going to make that funky w and cross through at least 2 times. Okay, so it's possible that f of x has fewer x-intercepts than g of x. Okay. All right. F of x has the same y-intercept as g of x? No, one's a 60, one's a -81. They're not the same. F of x has a greater y-intercept than g of x? No, that's not true either because f of x's y-intercept is -81. G of x's is positive 60. There's no way a negative number is bigger than a positive number. So B is the best answer for us here. Okay. All righty then. Next, we have number 25. The graph shows f of x in the xy plane. We're going to solve for f of x greater than or equal to 0. I circled that because what that really means is it's wherever y is greater than or equal to 0. So that means this is where we are above the x-axis because those are the y's that are positive. But we could be at 0 also. So this is where a marker or a highlighter comes in handy because then you can mark up the picture and highlight the areas on the graph that are above the x-axis or touching the x-axis because that would be where it equals 0. Well, obviously it's touching at the origin 0, 0, and we have this piece that's above the x and we have this piece that's above the x. So there are 3 zones in our graph that satisfy what they want, an f of x greater than or equal to 0. So the first zone, because we're starting at a -2, but it's using all the values to the left of that, that means to the left of -2, those are smaller numbers than -2. That means x has to be less than or equal to -2. And I know it's less than or equal to because we could be greater than or equal to 0. Then in the middle, it's just a single point. So right at that point, x equals 0 exactly. And then for 4, we're using 4, but then numbers to the right of 4, and numbers to the right of 4 are bigger than 4, so that would be x greater than or equal to 4. So on the number line, x equals 0 is the easiest. It's just a dot, a solid dot at 0 because we can equal 0 there. And then at -2, it's a solid dot also because it's less than or equal to, and numbers less than -2 are to the left. So you draw your arrow to the left. For x greater than or equal to 4, because we can equal the 4, it's a solid point, and numbers greater than 4 are to the right of 4. And that's it.